Welcome back everyone, Patrick here, moving on to another question dealing with trigonometry, another word problem. So you are standing on the roof of one building and looking at a taller building, which is 40 meters high. From your line of sight, the angle of elevation to the top of the taller building is 40 degrees, and to the bottom of it, the angle of depression is 52 degrees. And we have to figure out how far apart are the buildings. So as usual, let's try to draw a diagram with what we're working with here. So let's, this is the ground here. Let's say that this here is the, let's actually make this a little bit bigger. So let's say that this here is the smaller building, right? And you're standing on the roof of this building and you're looking at this taller building right here. Okay, and this taller building is 40 meters high, like that. And then what it's saying is that from here, from where you are on the roof of the smaller building, the angle of elevation to the top of the taller building, so if you're looking to this top here, then the angle of elevation is 40 degrees. Now remember, an angle of elevation is always from a horizontal, right? So this here would be the angle of elevation. An angle of depression is also in reference to a horizontal, which would be right there. That's the angle of elevation, that's the angle of depression. So if we draw a horizontal line like this, just to have a reference to where to draw this angle from, you know what, I'm just gonna create, not even a dotted line, I'll just create a line like that. So the angle of elevation to the top of the building, right, you're looking to the top of the building here, like that. This angle here is 40 degrees, like that. And then the angle of depression to the bottom of the building, from where you're looking, is like that. So this angle right here ends up being 52 degrees. And so what we have to solve for is we have to solve for how far apart the buildings are. So basically we're solving the distance from here to here. We could call that x. It's the same distance actually from here to here with this horizontal line that I drew, right? This distance, they're both the same. We could label that as x. So the x value is what we're going to solve for. Question is, how do we do it? Now we're going to have to use this 40 here somehow, and this is one of those questions where you're actually going to have to create two equations and have two unknowns and then solve for that x value. Now, if you think about it, this here, this distance from here, from the ground to the top of the taller building is 40 meters. And so what we can do is we can actually create two expressions for this length and then this length over here, because we're going to have to do that in order to use these two right angle triangles that we created. Notice we have a right angle triangle here, we have a right angle triangle here. And so what I'm going to do is I'm going to actually bring in a new variable. I'm going to let the height of the smaller building, the one you're standing on, be h, which means that if you think about it, because from here to here is h, well, that means from here to here is h as well. And then what that means is that from here to here, if the total distance is 40, like that, right? From this dot to this dot, it's 40. And then from this dot to this dot, it's h. Well, that means that the distance from here to here is 40 minus h. And the reason why you want to create an expression there is so you could have an expression for the side of this other right angle triangle. Okay, one more time. The total distance from here to here is 40. So if you think about it, if this was like, let's say 30, if this h was 30 from here to here, well then this distance would be 40 minus 30, which would give us 10. Okay, but we're not given specific values like that, so we have to create a variable here. So I'm going to let this distance here be h, which means that this distance here is 40 minus h. And now, because we have the sides of these two triangles labeled, if we draw those triangles out separately, so let's draw this top one here. We got this right angle triangle. This side is 40 minus h. This side here is x. That's the side that we're solving for. And then this angle here is 40 degrees, like that. And then if we draw this right angle triangle right here, so drawing that one, okay, this is 90 degrees. This is the same side, right? This side here is common in both this triangle, and it's also common in this triangle. So that side is x, same as this side. They're both the same side. And then we labeled this side to be h right here. And then we know that this angle right here is 52 degrees, like that. And now notice we have two right angle triangles that we created, and we have two variables to solve for, the x and the h. Okay, ultimately we're just solving for the x value, but we did have to bring this other variable h in order to get to solving to the x. And because we have two triangles now with two variables, we can create two equations. So we'll have two equations, two unknowns, then we can use substitution or elimination to solve for it.
Quick little intermission here. I wanted to mention a few things and we'll get right back into the video. Number one, if you're watching this on YouTube, you can go to the description box and there's a link that will take you to my website, allthingsmathematics.com, and there you can find all of the videos organized by chapter, by section, and there's also tests that you could try at the end of each unit. Number two, if you feel like you need tutoring at any point, I'm tutoring students 7 days a week over Zoom, both high school and university students, one-on-one and in groups. My contact details are on the website. You could text me and we could book a session. And finally, if you feel like you're getting any value from this video, if you could please like the video and subscribe to the channel, hit me up on all my socials. It does help me out a lot. If you feel like any of your friends can benefit, feel free to forward the website to them as well. And back to the video we go.
Okay, so I'm going to, let me think if I need anything else from here. I think we can erase this, right? So I took this diagram, created those two triangles, and I think we're good here. So what we can do, let's create two equations from both of these triangles. Now, because we're dealing with this angle, 40 degrees, notice that this side here is the adjacent side, the side that's attached to it. This side is attached to it as well, but notice that that side is across from the 90 degrees. So this side here is the hypotenuse, which means this other side that's attached to the 40 degrees is the adjacent side, which means that this side here is the opposite side. And which ratio deals with the opposite and the adjacent? The tan ratio. So we can go tan of 40 is equal to the opposite side, which is 40 minus h, over the adjacent side, which is x, like that. Okay, so we create an equation right here, and then from this triangle we can create another equation. So if we're dealing with this angle 52 degrees, notice that this side here is the adjacent side, and then this side here is the opposite side. And then this side here, we're not going to be using it, but that would be the hypotenuse, the side that's always across from the 90-degree angle. And so again, because we're dealing with the opposite and the adjacent, we can use the tan ratio on that. So we can go, let's maybe write it, I'll write it down here. So we'll have tan of 52 is equal to the opposite side, which is the h value, over the adjacent side, which is just the x value. And so now we got these two equations here, and then two unknowns to solve for, the h and then the x value. Question is, how can we solve for these? There's different ways. What I think I'm going to do is I'm probably just going to cross multiply these first. So we'll have x times tan 40. Let me just make sure that I got everything. Yeah, you know what? We don't need these triangles anymore. So I'm going to erase these just to give myself some room to work here. So what I'm going to do is I'm actually going to cross multiply these. 1 times 40 minus h would just give us 40 minus h, like that. And that's going to equal x times tan of 40, like this. So we have one equation right there. I'm trying to get rid of the fractions to make this a little bit more simple to deal with. And then what I'm going to do, I'm going to cross multiply here. So 1 times h is h, and then we'll have x times tan of 52, like that. And so what we can do now, notice that we have the h isolated here. So what I'm going to do is I'm actually going to take this expression, x times tan of 52, and then plug it in for this h value right there. And when I do that, I'll have 40 minus this expression, x times tan of 52, which would equal x times tan of 40, like that. And then notice here we end up with an equation with only one variable to solve for that x value. And so we can just, if you want, you could plug these into your calculator, the tan 52 and the tan 40. This, I'm going to actually write this here because, actually, no, we don't have to write this because we're not actually solving for the h, we're just solving for the x value. So really, we're just going to get our final solution here. We don't need the h value, we just needed it to create these other equations. But now that I subbed in for the h value, the x value, which is the distance between the two buildings, is ultimately what we're solving for. So once we solve this, we'll be good. So we'll have 40 minus, now tan of 52, if you plug that into your calculator, you'd get approximately 1.28. So you'll have 1.28, this x is still there, that'll be x, and this here would be 0.84x. Tan of 40 is approximately 0.84. And so what you could do here is you could bring this x value to the other side, so you'll have 40 equals 0.84x plus 1.28x would give you 2.12x here. Then you could divide both sides by 2.12 in order to get the x value by itself, and that's going to be approximately 18.9 meters, like that. And so that actually ends up being the final answer. Remember, the x value is what we let the distance between the two buildings be, and that's what they're asking for in the question. All right, so fairly complex question. Again, one of those where you got to take two triangles that you created, create two equations, and then you have two unknowns to solve for. We didn't have to solve for the h value in this case. We were able to directly get the x value, which is ultimately what we were looking for.
And that's a wrap for the video. Hopefully you enjoyed that. If you want to see more videos like this, please go to my website, allthingsmathematics.com. Over there, all of the videos are organized by chapter, by section. If you feel like you need tutoring at any point, you could also hit me up. My contact details are on the website. Enjoy your day, and I'll see you in the next one. Peace out.